Welcome friends, welcome back to our channel Crystal Learning. So today we will see the subject basic thermodynamics. Very good question is there. So if you know the formula then it's easy. Otherwise there is a confusion that what will be the right option. So many of the students have confusion in this question. That's why I am taking this question. Okay. So the question says the polytropic process undergone by a perfect gas. Okay, process gone by perfect gas are shown below in pressure volume coordinates. So 1 to 2 in forward direction it is moving, 1 to 3. Polytropic index is given of both the process. So it is saying which representation correctly of the above process in temperature entropy coordinates. So which will be the answer? It came in Engineering Services Mechanical 2008. So let's see the explanation. First of all, we will calculate the work transfer for closed system for a polytropic process. Okay. So for polytropic process, work done is given by this formula P1 V1 minus P2 V2 upon n minus 1. Okay, for closed system. Just pay attention for closed system. We are assuming this system to be a closed system. Then for heat transfer for this closed system will be polytropic heat, that is using first law of thermodynamics Q equal to U2 minus E1 plus W12. W12 is given by P1 V1 minus P2 V2 upon n minus 1, or using ideal gas relation MR T1 minus T2 upon n minus 1. Rearranging the term U2 minus E1, taking minus sign common, then it becomes MCV T1 minus T2. Okay, and Cv becomes R upon gamma minus 1, and this M R T1 will become P1 V1 minus P2 V2. Now we will take common P1 V1 minus P2 V2 term common. Okay, so now this we will get 1 upon n minus 1 minus of 1 upon gamma minus 1. We will take LCM n minus 1 upon gamma minus 1. Okay, so this will become gamma minus 1 minus time of n plus 1. So this term will cancel out and we will get gamma minus 1 upon gamma minus 1, gamma minus n upon gamma minus 1, and in bracket term P1 V1 minus P2 V2 upon n minus 1. We will rearrange this. So this P1 V1 minus P2 V2 upon n minus 1 is polytropic work. So the polytropic heat will be in terms of gamma minus n upon gamma minus 1 of polytropic work. So now we will calculate the entropy change of ideal gas for closed system. So we will start from this, that dT equal to gamma minus n upon gamma minus 1 equal to dW. So now we will put the term that is dW is PdV, and we will divide the term by T on the both sides. So this NR, and then we will integrate, that is 1 to 2 dq by T gamma minus n upon gamma minus 1 integration. It is constant, so it will come out of the integration. So it will be 1 to 2 P upon T dV. Now we will use the ideal gas relation, that is PV equal to MRT or P equal to MRT by V. This integration of 1 to 2 dq by T is entropy. So entropy will be S2 minus S1 gamma minus n upon gamma minus 1 integration of 1 to 2 MRT, replacing P with this. Okay, so MRT by V, T will cancel out, MR is constant, so it will come out of the integration, and in the integration inside there will be dV by V. So dV by V is ln V2 upon V1. So this is the very important formula for entropy change of polytropic process. Okay, this formula you have to keep in mind. Okay, this is the important formula. This ln V2 upon V1 is positive quantity because V2 is higher than V1. So ln of greater than 1 is always positive. R is always positive, M is always positive. So the value of S2 minus S1 will depend, whether it is positive or negative will depend on this quantity, that is gamma minus n divided by gamma minus 1. So now let's go back to the question and see the data given. So this was the data given for 1 to 2. 1 to 2, n is given 1.2. So S2 minus S1 will become, means we are just here seeing the value. Okay, so that is gamma minus n upon gamma minus 1. It will 1.4, gamma value is 1.4 minus of 1.2 divided by 1.4 minus 1. So this quantity is positive divided by some positive quantity. So it will come positive. S2 minus S1 will be positive. 1 to 2, 1 to 3, n is given 1.5. Okay. So using the same formula, that is S3 minus S1, 1.4 minus of 1.5 divided by 1.4 minus of 1. So that numerator will come negative, denominator is positive, so whole term will be negative. So this is the important thing we have to know, that change in entropy in 3 to 1 will come negative and 2 two one will come positive. Okay. So let's see in which we are getting this. So in these two options, first both of the option entropy change is positive. Okay. So this is wrong. For this both entropy change is negative. Negative. So this is also wrong. A and C option is wrong. Now coming down with other options, this 3 to 1, 3 to 1, it is coming negative because final entropy is decreasing. Okay, so when you will minus it, then it will come negative. That is 3 minus 1, it is negative. And 1 to 2 is coming positive, 1 to 2. So this option B is right. For this, just see 1 to 2 is coming negative and 3 minus 1 is coming as positive. Okay. So here we have seen 3 minus 1 is negative. So this is option is also wrong. So correct option is B. Option B is correct. So now you got the logic that how option B is going to be correct answer for this question, depending upon the formula which you have to be known for solving this question. Okay, so I hope you enjoyed the question and you got the concept that which option will be correct. So meet you next time with a new question and new concept. Till then, have a nice day.